thinking to do again little bit some glimpse on assemblers, and after that I will just start the macros. Macros is the third unit. But before that, let us look into the pass 1 and pass 2. As in the previous class, I have told you about lex and yak. Can anybody brief what is lex? I have told how the lex is resembled. What is lex and what is yak? Because your lab program, the journal which I am showing you, it all depends on the lex and yak only, because lex and yak are again the same tool as of the compilers. You may be knowing the compilers will be having the assemblers also, in the sense I must not tell like that. I must say compilers will be having all different the system programmings of the program execution. So same way, the lex and yak are also the same tool as of the compilers. Lex is also compiler, yak is also compiler. So lex and yak, these both compilers or these both different tools uses the Unix or the Linux shell too. So this is the lab journal which I have prepared for your class. So among that, we will be doing some few programs. So today, as I said, some glimpse on pass 1 and pass 2. So pass 1 and pass 2 are the both programs which we have to execute using the lex and yak tools, and that too in a platform called as Linux platform. That too in a which platform? Linux platform. So this lex and yak, are you observing the program like pass 1 assembler and program like pass 2 assembler, design of pass 1 assembler and design of pass 2 assemblers? So these both designs, anyhow it depends on my theory class which I have covered in the previous class also. So and the first program it says we have to recognize the lexical analyzers we have to do for a source code of the C program, that I have also shown you in the previous class, how the tokens will be recognized if you give the input. If you give the input something like this in the C program, and this you wrap it as a some text file and give this as the source code to the lex program, and this source code will generate or will identify who are the keywords, who are the strings, and who are the identifiers. So in such a way we have to build the program, and later it gives you the output at the command prompt only, there only, using the lex and yak tool. So that was the first program, and today I'm jumping because these all text editor and the TASMs we shall see using the Turbo C itself is a text editor simulation, that itself showing you it becomes the third program, and the TASM is nothing but working with the working with your assembler ASM assemblers. So that itself is a TASM tool, knowing about it. So introduction to TASM tool, introduction to text editor. The word file which I am showing, this itself is also called as a text editor, and in C program, in Turbo C and all, the editing part what you do, that itself is also called as the text editor. Like say for example the Turbo C, this itself is also called as the text editor. So these all are the introductory part which I would like to tell on the program 3. So that is all the journal briefing, and today the program 6th says about design of a pass 1 and design of pass 2. Design of pass 1 and design of pass 2. In pass 1, you should have always in mind that Compilers takes the high level language. See, I'm going with the program 6. Why? Because the first program is nothing but recognizing the units of C language, that is tokens of C language, that it should divide them into the classes. Like if it sees the hash include is nothing but a pre-processing statement and it is a keyword. Maybe their hash gets separated, but it will not take as separate. Why? Because it itself identifies that it is a keyword. And stdio.h also is also a keyword. And moving on to the void is also a keyword, and main is also a keyword, and after main two brackets you will be observing to become as a function. So those two brackets are treated to be as the operator. So in this way the tokens are recognized by the lex compiler. Now tell me, what is lex? Anybody? Yes, what is lex? Siddhi, Sonali, anybody? What is lex? What is yak? See, unless you people answer something, how it could be an interactive session? Maybe you people are doing with my class only, because I have observed with other faculty in department you will be interacting, but with my lecture, I don't know why you are keeping quiet. Yes, Sonali, Pratik, Abhishek. See, the students are leaving. Monali has left. Hmm? Chaitali also is leaving. Is there anybody in the class? Abhishek, Prashant, Akanksha, Saurabh, Siddhi, Tajmin, Pratik, Kajal. Okay, fine. I have to do my job. You people are not responding, and later you will be telling my session was not interactive. However, you wish. Okay. And also in the previous class, I have told you about some glimpse on Lexania. Lex is nothing but a lexical analyzer. So you should remember the two. You should remember the phases of the compiler to move with the any assemblers. Phases of compilers are what? Lexical analyzer, then syntactical analyzer, semantic analyzer, then after semantic analyzing, intermediate code generation and code optimization and code generation. So these are the 6 steps of any compiler. Any compiler means it can be a compiler of the Lex, it can be a compiler of Yak, it can be a compiler of the not only the Turbo C, it can be a compiler of Java, anybody. So these compilers, what they do, take they take the input of the high level language as the input or the source program as high level language and convert that into the assembly language. Convert that into what? Assembly language. So high level language to low level language. So assembly language is a 0 and 1 understanding. 0 and 1. Every computer understands or processes the high level language into zeros and one, which is nothing but a computer understandable language. So this computer understandable language processes the high level language, sorry, this compiler processes the high level language into the low level language. That itself you should keep in mind. Now lex part is nothing but the lex tool what we are using for the lab purpose. The lex tool which we are using for the lab purpose, that is nothing but lexical analyzer, which is a first part. The first part it does. So when it does the first part, it converts, because it itself is a lex tool, and lex tool is having the itself like converting that into the C tokens, converting that into C tokens by saying yes lex dot y dot C. So by this it processes it into C tokens, and later, and also I have told you that how is the format of a lex. Lex has also got the three format, that is the declaration part, the body of the lex, which is nothing but the which is nothing but the pattern of the lex with the actions, and next which is nothing but the next it is nothing but the auxiliary functions. Next it is nothing but the auxiliary functions, and the yak also has got the three. Yak also has got the same format, that is the declaration part and the but here yak is resembling to the parse tree. Yak is resembling to the parse tree, parser tree, or it is also called as parser, and it is the second phase of the compiler. Yak resembles to the second phase of the compiler. Now what is the second phase of the compiler after lexical analysis? Syntax analysis. After lexical analysis, syntax analysis. So here the working of the lex, how does it get separated? By the two double percentages that which I am showing. The definition part is separated by two double percentages, and the rule which is nothing but the patterns. The rules part again is separated by the double percentage to get into the user subroutine, that is the functions, any user defined functions. So here let me tell you the code of that, some sample code. Even in the previous class also I have told you. So today directly I'll be telling you about the lex format. Suppose I have here the pattern for digits, that is from 0 to 9, and here which I am giving the pattern as digit, and which I am giving the pattern as which I am giving the pattern in the square bracket as 0 to 9, and for letter in the square bracket from A to Z and small a to Z. So if I want this pattern to be defined in a lex, so how I would define? So first of all, I consider them as whatever the pattern are there, I consider by using some variable, something like to resemble them as letter or digit. It can be letter or digit. So by using the count variable, have them in the I can have them whatever the user is giving. So it echoes in the count. So it echoes, you see here, by using the percentage d, it echoes them in the count. So how the compilation takes place here? Suppose if I have named this program as lex or abc1, abc or some a program dot l is a lex program, and this lex program, after saving that in their any platform, Unix or Linux platform, what we have to do, the second step for compiling, you should tell as whatever the file you have typed, you should tell it as lex, save that file as some name, and give the extension as .l, and call it by lex processor, lex filename .l. Suppose you have named the file name as abc.l. abc.l should be processed by lex compiler. So by this processing, it generates the file called as lex.yy.c. lex.yy.c. because it itself is a separate compiler, because it has to see for all the processing of the tokens, whatever the patterns are given. So it itself takes that into, because it is a high level language, we have written in a high level language, and Lex is a tool which processes them, the high level into the low language. So it has to identify, so that's what it is called as lexical analysis. So it constructs lex.yy.c as a C file, and this C file is again constructed C function using the yylex. Where we have taken yylex, we have taken yylex in the main program, because here the file which we have prepared, it has processed it into C, and this C program, because it has been converted into C, the Lex program is being converted into C. Now, because Lex is a separate tool, itself is only doing a part of lexical analysis. Lex is a separate tool. As of a compiler only, we can call it as compiler. But what it is doing, it is only doing the lexical part, and later after doing the lexical analysis, it is giving it to the C compiler. So how it is giving to the C compiler? By saying as the function called yylex. So here we have written by saying the function called as, by calling the function called as yylex. By this, what happens? It starts compiling, and also links the library. It also links the library functions what is being used in the Lex program, and later it generates one object file called as dot slash. Later it's by executing in at the third step lex.yy.c, because it was processed, the Lex program was being processed to C program, and here also it has been compiled and linked. Also it has been compiled and linked to generate the obj file. So catch that obj file and put that in the command prompt, like saying as dot slash a dot out, and execute it. If no errors are there in the file, it starts giving you the, based on the program, it can give you the output. Now the output of that program, what it could be, because I have told this program only to recognize the letters and the digits. Letters and the digits. It can be any number, 0 or any number. If you don't give anything, it will tell it as. So if at all, at the output, if you have given A, it should tell it as a letter. And at the output, maybe console screen, you have given something like digit called as 9. So it should tell it as a digit. So whatever you are giving, so this is that program. So what I have recalled here, so let us go to the sixth program. That is nothing but the pass 1 and pass 2. Pass 1 and pass 2, and after that I will clear you one doubt here. The variant 1 and variant 2. Variant 1 and variant 2. And after that, I may also clear you the forward reference doubt, and we shall solve some of the exercises. Okay. So here, pass 1 of the Lex program. How the Lex executes? Do you remember? Yes, anybody, how the Lex executes? Do you have the system now? Yes. Do you have the system now? Shivani? Anybody? All of you ensure the C program, Turbo C or the Lex, get installed Lex in your system. Otherwise, we can't do the lab programs. Pratik? Pratik? Am I audible? Aparna? Yes, am I audible? Please answer, am I audible? Abhishek, do you all have either Turbo C or Lex in your system? Lex tool. Yes, Shivani, anybody? Akanksha, Diksha, Prithvij, Jitender, Geeta, Gauri, Gaurav, Gaurav. Do you have anybody? The Lex tool? Well, you need to have the Lex tool in your system. Please get installed your Lex tool. It's an open software you can install. Yes, then only we can do the lab. Every fifth, I think Monday, Tuesday, Wednesday. Wednesday will be your lab session again. I may handle the lab session. Every 1 hour will be the lab session. So you should compulsory come with your lab. Sorry, the lab sessions prepared. At least minimum softwares you should have in that. You should have either the Turbo C or you should have either the Lex tool. Is that clear? Please answer. Sonali, Shruti, Sanika, Kajal, Pranesh, Onkar. Today Onkar is not there.
जी मैडम कर लेंगे डाउनलोड हम।
तो अभी मैंने एक प्रोग्राम बोला which identifies the tokens of a C language. Will you come up with that next for the Wednesday class? Now how
ये
the Lex
कंपाइलेशन और एक बार बताइए फिर से समझ में नहीं आया।
compiler कौन से?
कंपाइलेशन और रनिंग एक बार बताइए।
अच्छा, very good. First, what you need to do, you should type the program. If you are having, which platform you want to do? Windows. If you are doing in Windows, you should have C, Turbo C. Hello. Yes.
हाँ
Pranesh,
ठीक है मैडम, कंपाइलेशन बताइए एक बार और
which
कैसे कर।
हाँ, Lex compilation.
हाँ लेक्स कंपाइलेशन।
Okay. Now suppose, how is the format of the Lex you came to know, na? It has got declaration, rule part and function part. So here in the rule part, sorry, in the declaration part, I have declared something here. Assume that some variable is here, something like a count. I want to count only the whatever I am giving. Whatever I am giving means I may be giving. I want to know whatever the digits or whatever the letters which are typed from the keyboard. A compiler should recognize that A is a letter. If I type a digit like 7, 7 is a digit. Or if I type some character, some other character, special character, something like star or percentage, so it should identify that it is a operator. So to that extent I have not done here. Only pattern what I have given, see here, sorry, the bracket, flower bracket indicates that the patterns, flower bracket indicates that the pattern which I am giving, the pattern, first compulsory pattern which I have given as letter, and next compulsory pattern which I have given as letter or digit. And next to this I have made this as regular expression by saying as a star. That means first compulsory pattern is a letter, and this whatever is given in bracket next part, this is given by a star. This shows that the match can be 0 or more number of times, 0 or more number of times. And this is wrapped here because it is only a pattern which I am telling a Lex to recognize that. Once the Lex processes this pattern or it is encountered here, it identifies that it will prepare itself that a letter, if it is given, it should identify it as a letter. So for this I have done here some echoing back so that it should be a interactive program. So here whatever this was observed, encountered, so it should be encountered by a variable that yes, a letter or a digit is encountered by saying as count. So here the count indicates it as a integer part. Why? Because I'm just counting what the letter or digits, whatever the keys which I'm pressing from the keyboard, that should be counted. So this is the, as in that small part of the program, and this program just I made it as an interactive to be, so saying that the number of identifiers whatever we are giving is something like percentage D, which is given in the count declaration, sorry, which is given in the declaration part. So this is how the program, whatever you are giving, either A, B, C, D, or whatever you are giving, any character, any digits from the keyboard, it should be identified as the identifier. So here it is written. Now this format, from here, this format, it becomes as, and what the pattern which I have given? The pattern which I have given here is the digits or means how the Lex understands. It understands by whenever digit is given as the pattern, it encounters or it understands that I should recognize that from 0 to 9. And the next pattern letter, it will understand that the letter means from A to Z or some small a to Z. So in this way the patterns are given. So that is what the pattern, and this is what the pattern are called here, and they are made as the rule, compulsory rule part, compulsory the rule part, and this is what the function. What function I have taken here? Because Lex is what part? Pranesh, can you tell Lex is what part? Lex is a compiler. Lex resembles in a compiler which phase? Lex is only doing a lexical analysis. Lex is doing only a lexical analysis. After lexical analysis, syntax analysis, semantic analysis, intermediate code generation, then the code optimization, then after the code optimization, code generation. So rest remaining part, these all are done by the C compiler. That's what here the int main, in this main we are wrapping that yylex to be processed to the C. So to do this, what the source file, which is our lex is a source file which is only doing a lexical part, that can be processed by saying a command called as lex. After a file is done in after a file is saved in with the extension called as .l, what you need to do, you need to be processed by calling the command called as lex, which processes the lex file. Lex processes the lex file. Please note down everybody. Once you save the file as lex, abc.l. Assume that abc.l is a lex file, and once you save that as lex file, the next step is to be process that lex file into lex. So using the command called as lex and call the file name .l. So what this is done? This generates the output. A C file is generated, that is using the lex.yy.c, and which constructs a C function of yy lex, which we have given here. That means it is doing only a lexical part and giving to the this lexical part is given to the C compiler. Now the lexical part which is given to the C here .c, which is given to the C compiler, it compiles and links the lex library. It compiles and links the lex library, and here it is ready to generate the object file. Catch that object file and execute. Will it run it by pressing the enter key? So it will execute your file. Execute your file. So how it will execute your file? Whatever the token which you are giving, whatever the token, in the sense you may be giving something like the A, B, or you may be giving something like 0, or you may be giving something like plus. So it will identify them as into different classes of the tokens of the C language. C language, or now this is a lex part, so it identifies them into the lex language. That is lexical analysis. Yes, Pranesh, have you understood? Have you noted the step? Simple step. First save the file with extension .l, and next process that .l by saying the command called as lex with the file name called as whatever .l, and this should be processed to generate the C tokens. So that is lex.yy.c should be given the third command. So with this it is ready to give you the object file, and catch that object file and execute by saying yes /a.out. Yes, Pranesh, got it? Now the pass one. Shall I go with the pass one? Yes. What the pass one does? Pass one does, or how is the structure of the pass one? As you all know the story of the compilers, compiler takes the high level language and generates that into machine language. Sorry, I should not say exactly as machine language. It will generate into assembly language. That is 0 and 1. That is low level language. And this low level language which is ready for the compilers. Now the compiler, what it will do? It will take that assembly language and processes that into 2 times. That is 2 times scan it will do. That is pass 1 and pass 2. During the pass 1, what will be generated? The databases will be generated, that is the data structure, and the intermediate code will be generated. So let us do one exercise. So that becomes your lab program 5 and 6 also. Pass 1 is, I think once again I should go here. Pass 1 is what? Your lab structure pass 1 is, which program means your lab program is pass 1 is 6th program, and pass 2 is the 7th program. So that also performs here. So note down everybody. I'll give you the sample code of the directly. Now what the input to be given here for pass 1? You should give the input as assembly code. What the input to be given? Input should be given as assembly code. So here I think this is all what the story which I have told. It is all the same I have written here. The purpose of the pass 1 to define the symbol tables and literal tables, and also the assembly language, which is assembly language which will take as the input, and here it will generate the pass 1, it will generate as IC, which is nothing but intermediate code, and in the pass 2 what it will do, it will directly generate the object code, and still it refines the intermediate code. it refines the intermediate code. For as the source program will be here the assembly program, and it start creating the databases of the object, start creating the databases of the symbol table and the literal table, and also the literal pool, because once the literal table is there, it shows the continuous that the literal is encountered, so that it will also build an another database, that is literal pool. So it constructs three table and later it constructs the intermediate code. Now, if at all, if it encounters the start, end, or whatever the declarative parts, so it should tell those as what? Either the constant, or either the assembler directive, or some imperative statements, or some declarative languages, some, that is DL, that means the declarative assembly language. So in declarative assembly language, again we have DS and DC. So if it encounters in a program all such different what it has to do, so these all are the different imperative statements, different declarations. So if it encounters, if a location counter see all such things or scans during the pass one, so now it should, whenever it sees, it should also it should keep the track of the location counter. So it should do. And one more thing, in the theoretical part I have not told here, it also determines the length of the machine code. How the length of the machine code? Like say for example, what is the type of byte, or what is the type of some label or symbol. So like that, it also determines the length of the labels or symbols what is appeared in the source program. Source program here it is taken as the assembly program for assemblers. So this this is the flowchart which I have repeated in the last class also. I need not to tell more on that. And this is how the assembly pseudo code of the past one. Whatever I have told, it is in the same. Once again you can read it, you can go through it, and what it does in the form, if it observes the label or opcode or operand, what it has to do, or if there is a label, it should add it to the symbol table, and if it is already there, so it should not add, and if it encounters something like opcode, what it has to do, it has to keep them in the format, whether that opcode is a which type, byte or is a word or is a byte, and whether if the opcode is an instruction, what it has to do, it has to keep them in the pairing order, like it has to keep them in the tuple form, like which class it belongs to and what is its machine code, so it has to take that, its object code also, sorry, what is its machine code. Say for example, add is 1, sub is 2, mul is 3, like that. Or if it is having some other assembler directive, means it should assembler directive again has got start, end, then also the LTORG and origin. These are nothing but the assembler's directive or advanced assembler directive. And again, if they see, if the scanner sees such assembler directive, what it has to do, it has to again go to that part, and once it sees the start, it should also see the end. So that's what here it is told as increment part. So just go deeply into this algorithm, whatever I have told. Again, it takes the same time. So today I will be explaining of this example. What is our example? Our example is all of you please hold pen and paper. Yes, we are going to solve this example, any example. In the last class also I have given some example. So what the past one will be doing here, what the past one will be doing, you should be ready with now the past one is ready to take or ready to scan the code, and it starts doing the symbol table and retrieve table and pull table. You should have in this mind. So pass 1 is ready to generate now the intermediate code. Now at this time, here the address which indicates as the location counter to be started as at 200. So anybody, what will do, what the source intermediate code is generated here is start pairing. Yes, please do, otherwise you won't get. Unless and until you do, you won't get. Because last time I have done one example before the before the revision of the first chapter. So after this only I have begun the revision of first chapter. Do you remember? Now this is what? Start is what? Assembler directive. Start is what? Assembler directive. And assembler directive for mnemonic code of the assembler directive for start is what? 01. So its category starts as 01. And 200 is what? 200 is what? 200 is seems to be something like constant, and it is nothing but the value of 200. Next code, next intermediate code for this. Now this is a sample source program or assembly program, which assume that this assembly program is generated by what? Is generated by the compiler. Compiler takes high level language and generates it into low level assembly language. Now this is generated by assume that compiler, and this which is acting as the source program for the assemblers. Before that, I will show you here the variant so that you will be understanding. Because direct example I have taken here in this. In this example, start. Say for example, start at this location 200 something I have given. So it is nothing but very intermediate code. It's assembler directive. And start. What is the code of a start? I have told you in the beginning of the assemblers, every instruction of assembly language have got the machine code, have got their own code, which is nothing but opcode, or it is also called as machine code. So the start of this code is what? Its code is 01. And what is 200? 200 is something like this. C comma C is a constant. 200 is what? 200 is a constant. And what is its value? 200. And next is read. Read is nothing but a imperative statement. Read is a imperative statement. And what is its value? Its value is 9. And what is the value of write? Write is 10. Just go through all the in your microprocessor. I hope you have come to know the different categories of the assembly statements. What is their code? What is their instruction code? So read is an instruction, and what is its instruction is 9. Next is A. A is encountered to be as a symbol table, so it directly goes into the symbol table. Directly it goes into the symbol table. Now, when it has A is the first which has gone to the symbol table, and what is its index? First symbol, it's a 01. And what is its type? Type is A is a symbol, and from symbol table, what is its index? First value. What is it? Means it has gone first time. So what is its index? Index is 01, means 1. Next is label here. Loop, and again instruction mover, and again argument and label. Let me clarify this loop. Loop will take at last. Now let me go with the instruction. Instruction move is nothing but what? Move is a instruction which is of imperative statement, and what is its value? Its value is 4. Next, AREG is a argument. Sorry, is a register. Sorry, it is a register. You may be knowing AX register, BX, CX and DX, 8086 registers. So A is having 1, B is having the category of 2 and C is having 3 and D is having 4. So like this, A register, A is one category. A is one category. Now label A. This is a label A again, sorry, not label, symbol A. This symbol A already it is encountered in the symbol table. Again, it will not be pushed into the symbol table. So it is the same. A is a symbol and its index is 0, 1. Now here still there are some set of codes which are given by dash dot dot. So moving on to the next, sub. Sub is an instruction, assembly instruction, and it is an imperative statement. And what is its code? Add is 1. For all the arithmetic operators, again they also fall in the category of add is 1, sub is 2, mul is 3, division is 4. So let me, here I have seen the past one has seen the sub, and sub is 0 2. Sub is 0 2 because add is 0 1. Now moving on to the, again register is found here, and which type of register? Again A is a register, so A is 1. Now here equal with single quote 1. This is nothing but a literal. Now here a literal is encountered, so this is the first literal, a first scan or a pass one. A first literal is encountered, so it's construct a database or a data structure of literal table, and this will be pushed onto the literal table. From the literal table, it is index is 1. But what it is? It is not a symbol, it is a literal. So L. So here it is L. And what it is? It is nothing but a literal L, and it is a first literal in the literal table. So it is 0 1. Its index is 0 1. Now BC. BC is also nothing but a condition code statement in the assembly language program. So BC also has got its own code. What is its own code? If you go with the Dhamdre book, it is given in the Dhamdre book. The code of BC is nothing but 7. The code of BC given is nothing but 7. It is nothing but branch on condition. What it is doing? Branch on condition. So what branch it is taking? Greater than branch it is taking. So for greater than, less than, equal to, again they also have the code, machine code. So greater than is 07, sorry, greater than is 4, less than is 5, equal is 6, like that. So go through the instructions of the assembly language. Well, in Dhamdre or in some other 8086 book it will be given. So just find out all the, you should have to do this intermediate code, you should have the reference of only the instruction code. You should have the reference of machine code, their instruction code. What is their instruction code or the statement codes? So here BC is a branch on code, and its code is branch on condition, and its code is 7. Now moving on to the GT. GT is a greater than, branching on greater than, and its code is 4. Its code is 4. Now loop is nothing but already which is encountered, So this loop which was told here, loop is nothing but a label, and it is moving to the symbol table, and it is found to be a second, that's what it is, symbol second. Why? Because first what is there in the symbol table? A is there in the symbol table. Next, loop is there in the symbol table. Here also loop was, I should have written here one more. If I go with this line, but it is ignored. Why? Because we are just following here the instruction, from the instruction operand 1 and operand 2 we are following, like that. So here there is no problem if I pair the loop also, if I pair the label also here itself, but you will be having the confusion. That's what here it will be taken as 4 pairs. So you will be having the confusion. That's what it was not taken. So it was ignored here. So here only one funda we have followed here. Only the instruction operand 1 and operand 2 codes are formed. So here operand 1 is greater than and operand 2 is what? Loop. So what is the loop? Loop already if you follow this also the same type. It will say as symbol. How its pair is, the class itself is symbol comma 2. Why? Because symbol A is the first index and loop is the second index. So the same thing is repeated here. Loop is a symbol and it is a second index, that is 0 2. Second time it has gone means it is a second scan or second time it has encountered. First time A is encountered in the symbol table and next time loop is encountered in the symbol table. That's what here it is 2. That's what A here it is 0 1. A here it is 0 1. Loop is 0 2. Next is nothing but stop. As start is having 0 1, stop is also having a 0 0. What 0 0? Here it is written wrong. Stop is also a assembler directive. Stop is also a assembler directive and it is having the code as 0 0. It is having the code as 0 0. Moving on to the declaration part. Here it is A is declared. So here one more thing you can observe. A is treated to be as a forward reference. A is treated to be here as a forward reference. It just reads and it just keeps blank for the address to be found. Maybe here address location 200, but here you should not think that it as a 201. A is at the address called as 201. No. Why? Because here somewhere it will be found, it will have in the assembler mind that it will take here overhead. What overhead in the sense? It will just process each and every line and one time there will be there that A is encountered. Oh, here A is there and it will think that A is also declared and here it will have the address. It will have the here address location is not mentioned here in this example. So I'll look into another example where the address locations are mentioned. So here, now moving on to this instruction for the generation of the intermediate code. Now A is nothing but a declarative, A is nothing but what? A is a symbol. For A is a symbol, so here again it is in the third part, this is in the label part. So here what method we are following means we are following the method of only the instruction and the operands. So let me go with DS. DS is nothing but the declarative part of the assembly language. Declarative part of the assembly language. So DL. And what is DS code? DS code is 02. DC is what? Declare storage. DS is nothing but declare storage. So for declare storage, what the value we have? We have 02. And for DC at the same time we have 01 in the assembly language program. The instruction or the instruction of this and its code is 02 and DC is 01. So here DL is nothing but declare assembly language. Declare assembly language, it comes into the part of category of or the class of directive declarations or declarations, I must say, assembly declarations. And 02 is the 02 is the code of DS. Now moving on to 1. What is 1? 1 is called as the constant and same as of this. 1 is called as the constant. And what is its value? Its value is 1. What is its value? Its value is 1. Now, LTORG. Now, this is an advanced assembler directive. LTORG is an advanced assembler directive. Whenever LTORG is seen, it goes to the category of declaration. One thing you should remember always, whenever you see LTORG, and whenever you see the origin, anyhow origin is nothing but the assembler directive. Origin is also an assembler directive, and LTORG is also an advanced declaration part. But here what is being done means what is being done here means the declaration part of LTORG, which is considered to be the category of the declaration of the assembly language, and its code is 05. Its code is 05. Now what does it mean means the literal pool will be started. The literal pool will be started. Now here LTORG, what in the literal total number of how many in the literal table, in the literal table total number of how many literals are there, that shows. So here further code which we have not given. So further it says that total how many codes are there in the literal table, it tells like that. But this happens backend only, that is the data structure in the database, the database of the literal table. So how many tables are here? Two tables, that is symbol table and literal table. In symbol table what is there? A and loop is there, and in literal table what is there? Only one is there, and it is at the index called as 0, 0 1, and it is at the index called as 0 1. And what the whenever LTORG is encountered, a pool will be started. Literal pool will be started. Literal pool gives you the total number of the literals of a literal table. How many literals are there, so called. Okay, so that is how the variant one. This is a variant one in the sense there are two set of codes for the same code. That is for the same code, there are two set of two different two different processing is being taken here. Now here, if you observe this code, directly we have mentioned here the what it is doing. What it is doing means it is being directly pushing the even the registers also into the memory during the pass one. During the this is all the steps of the pass one only I have told. This is also another different variation I am telling for the generation of the intermediate code. Same example. Now here look into this example. What the difference I will just tell. The difference is that move is a imperative statement and its code is 04, and here AREG is a register, and it is a register, and it is what the value, its value is 1, its value is 1. So wherever you are encountering here the registers, wherever you are seeing the operands, operand 1 and operand 2, if you observe here operand 1 and operand 2, so wherever you are seeing the system part, the file part, or the file part, which it has to go into the memory also, which it has to go into the memory also. In the first part, see here, in variant also what we have done, a register's value 1 is also pushed into the memory. So here if you observe, a register is not pushed into the memory, it is automatically understood. So why we need to push that register also into the memory? So in the variant 2, in the variant 2, what is being observed means a memory is being little bit saved. A memory is little bit saved. So that is what we need not to send, because such things directly it can take from the file. Such things, which such things means where there is a unnecessary of pushing the code into the memory. So there the more memory utilizing will happen. Means in variant 1 more utilization of memory is observed, whereas here in variant 2 less utilization of memory is observed. Means what is required, a minimum intermediate code is pushed into the memory. A minimum intermediate code is pushed into the memory. The rest it will take from the source file only, because directly it can hit the source file and collect the information for the generation of the next, or next in the sense past 2, for past 2. So here a little bit saving of memory you can observe. So here this part which is of the variant 1 and this part which is of the variant 2. See here in the past one it has taken large amount of past one it has taken the large amount of memory. There was free space of memory, and how much it has used, large part of the memory it has used, large part of the memory it has used during the past two. Why? Because it has to go back, and take the value of the code what is being generated here. So what is being generated here, and therefore here more memory is used. And in here in past 2, sorry, in variant 2, the less utilization of memory is used, the less utilization of memory is used. So here during, it feels very difficult for a assembler, so that it uses more utilization of memory during the past 2 here, because the work area itself, it is doing in such a way that it is directly taking from the file. How much is required intermediate code, that much it will take. So that is nothing but which will be helpful for the pass to for the generation of the object code. So one thing you should understand, where there is a, where there is a minimum possibility of the code generation, that is well and good. Where there is a more number of possibility of the code generation, that utilizes more memory, so that is what the variant 1 and variant 2. So I will read out here variant 1 and variant 2 what it says. Variant 1 says the data structures such as the symbols table constructed by the pass one are passed into the memory, which is are passed into the memory, while the intermediate code is pre-assembled and is written in the file 1. Since the pass 1 performs the more processing than pass 2. Since the pass 1 performs more processing than the pass 2. So here pass 1 is doing more processing because it is converting everything, even the register code also it is converting. But whereas in variant 2 register code it was not converted. Means here what is being converted, only the instruction. What is being converted to machine code, only the instructions are converted in the variant 2. So here less amount of memory is utilized in the past one also and in past 2 also. So here what happens, in variant 1 more memory is utilized in the past one, and also here more memory is utilized here in past 1, and in past 2, compared to past 1, more memory is utilized. Why? Because it has to work out, it has to do less working in the past 2. At the whole, the variant 1 uses more memory and variant 2 uses less memory. Why? Because both are doing little job. Past 1 is also working and past 2 is also working. That is all. Yes, one more doubt I'll be answering. What is forward reference? This was solved using forward reference. To solve the forward reference, we have to solve using the piggybacking, or it is also called as piggy patching. So we can solve such. What does it happens? The forward reference, because this is also useful for the assemblers, sorry, macros, to understand, so that you can clearly understand. Say for example, I'll work out with some example. Yes, Pranesh, are you understanding? Anybody? So we can start macros na, or you want to solve some examples? This is the example. Yes, anybody? Pranesh, Akanksha, Pranali. Can you solve this example? So this is what the machine code generated. Yes, Pranesh, Pranali. Or shall I have take attendance? After attendance, will you solve this? And the same example should be done for pass 1 for the lab 6. Take this assignment and tell me about the intermediate code. In next class, I will be asking. Tell me about its intermediate code. Show with the construction of the symbol table and literal table. Yes, next example, what you will get? Move is what type? Imperative statement. And move has got what value? Yes, move is having the value called as 4. Move is having a value called as 5. Remember, move is having the value called as 4. And reg is having what? Is a first category of the register. And if you want, you can keep, if you want to go with the variant 1, you can also go with the variant 1. I am going with the variant 1 so that for better generation of the code here itself in pass 1 only. Variant 1 uses, variant 1 works in pass 1 also, and variant 1 works in pass 2 also. In pass 2 it works less, and in variant 2 minimum working is there in pass 1, and both the pass 1 and pass 2 they minimally work. So less utilization of memory is observed in variant 2. So I am following here variant 1. Should I have to take attendance? You are not doing any work. Unless and until you do, you won't get. At least tell me now. What is here next? What I should do for AREG? AREG is what? AREG is what? AREG is a register, and it is a category of 1. Next is observed as operand 2, B. B is what? A symbol, and it is a index is 1. Why? Because first symbol is observed in a symbol table. Moving on to the next intermediate code. Can anybody tell? Move M belongs to what code, and which class? Imperative statement it is. And move M is having a code of 5, and BREG is nothing but it is a second category of the register, so its code is 2. Its code is what? 2. And equal to 2 with quote. This shows that it is a literal. This shows that it is a literal. So for literal, what we need to have, it is pushed into the literal table. So it is a symbol called as literal. It is pushed into the literal table. So it is a L and it's a first index 01. Why? Because first literal is seen or scanned or passed by the compiler, Lex compiler. Next is move M. Again, move M is an imperative statement and its category is its code. Its category is imperative statement and its code is 05 as move R is 04. Understanding? Yes, should I have to take attendance? Pranesh, at least you tell na. Pranesh, Onkar, Abhishek, ओनकार, अभिषेक, प्रणली, गीतांजलि.
वो एलसी वैल्यू कितनी होगी उस मूव एम की?
हाँ ऐसे पूछो. कौन सा
मूव एम की?
हाँ हाँ
मूव एम की एलसी वैल्यू कितनी हुई?
मूव एम.
जी
one second. Move M. Move M is 5, no? See, it all depends on the machine. It's not like, see, I assume that I'm following 8086 or I'm following 8085. It all depends on what type of assembler we are having in the system. Okay, based on its assembler version, they themselves have the code. But assume that for move R, very good doubt you are asking. For move R, the assembly code is 4, and for move M, assembly code is 5. Getting? Pranesh, अब प्राणेश है ना? Hello. Move M is 5. See here, I thought you'll be doing, but no students are doing. See, unless and until you work on yourself, you will not be able to get the intermediate code understanding. So this is very useful and this is very important to understand the intermediate code generation. Once the intermediate code generation is done and pass to
ये
take
उसका लिटरल, मैडम ये उसका लिटरल कंटेंट उसका 5 कैसे हुआ, ये समझ में नहीं आया मुझे.
लिटल कंटेंट 5 कैसे हुआ? नहीं, ये तो कोड दिया हुआ सो है ना. It is a assembly source program na. It is a source program of a high level language. पिछली बार मैंने बताया था ना, हाई लेवल लैंग्वेज. सपोज हाई लेवल लैंग्वेज एक स्टेटमेंट है, C is equal to A plus B. एवरी मशीन ना इट अंडरस्टैंड्स हाई लेवल लैंग्वेज. ये बात दिमाग में रहना चाहिए. उसके बाद क्या होता है, कंपाइलर जो भी कंपाइलर, अब मैं किस में कर रही हूँ, अज्यूम दैट आई एम डूइंग इन लेक्स इज आल्सो कंपाइलर, याक इज आल्सो कंपाइलर, टर्बो सी इज आल्सो कंपाइलर. टर्बो सी में हम कौन सा लैंग्वेज देते हैं, हमारा सी लैंग्वेज हाई लेवल लैंग्वेज है. वो इंटरनली क्या करता है, उसमें असेंबलर रहता है, पहले कंपाइल करके क्या जनरेट करता है, ऐसे वाला कोड. ये बोल रहे ना आपको, ये 2 कैसा आया, ये 5 कैसा आया, इक्वल टू, वो कोड जैसा है, हमारा हाई लेवल कोड जैसा है, उसके हिसाब से जनरेट होता है.
नहीं मैडम, मैं ऑप कोड बोल रहा हूँ, मैं ऑप कोड बोल रहा हूँ 05.
ये 05 ऑप कोड एवरी मशीन विल हैव नो. मैं आपको वो लिस्ट बताना क्या, ऑप कोड्स के वैल्यू कौन कौन से किस किस में है, मैं आपको बुक में से पढ़ा के बोलती हूँ. आपके पास बुक
हाँ
है, धमद्रे
नहीं है,
बुक है?
ये समझ में नहीं आ रहा है ना, इसकी वजह से
अच्छा.
सिर्फ
वेरी गुड
देखना पड़
वेरी
रहा
गुड.
है क्या
हाँ
लिखा
हाँ,
है.
वन सेकेंड, आई विल रीड आउट ऑल द वैल्यूज. हाँ, कैन यू नोट इट डाउन? Otherwise, shall I take a pic and send you?
ये आप
One
ये आप हमारे व्हाट्सएप ग्रुप में शेयर कीजिए,
one
कंफर्टेबल
second.
रहेगा।
Ha. One second. Still time is there. Let us discuss like this only, because this class will not. It is very hard you people to understand, and it is very tough to. I mean, to make you to understand also. See, I am sending in WhatsApp group. Can you see now? From the Dhamdra book, I am sending you. प्राणेश, क्या ऑन कर है आप? एसपी ग्रुप में देखो, अभी डाली जो मैं। देख रहे प्राणेश? प्राणेश
हाँ
ओनकार।
देख रहा हूँ, देख रहा हूँ,
हाँ
देख रहा हूँ।
हाँ, मैंने वेरिएंट में एक स्टॉप बोलकर लिया था, उसका कोड 00 लिया था, याद आया? वेरिएंट में, वेरिएंट एग्जाम्पल, वेरिएंट 1, वेरिएंट 2। ये वेरिएंट 1, वेरिएंट 2 क्या है? सेम एग्जाम्पल को दो कैसे पास 1 कम कोड करता है, और कैसे पास 2 कम कोड लेते हुए भी कैसे लेस मेमोरी लेता है, और पास 1 में और पास 2 में, ये वेरिएंट 2 में हम देखेंगे। डिड यू गॉट? सी हियर कोड्स, आर यू सीइंग प्राणेश? एसपी ग्रुप में डाला है मैंने।
हाँ अब आया है समझ में, क्योंकि ये 4 मुंह आ रहे हैं और 5 मुंह में। ठीक है, ठीक है।
हाँ हाँ, चार क्या
धन्यवाद।
आया? चार क्या आया? एंड इट इज ए विच कैटेगरी? सी हियर, स्टार्ट, स्टॉप, एंड, ये सब भी क्या है? एंड आई शुड नॉट टेल, क्योंकि स्टार्ट होने के बाद स्टॉप इधर कौन से बुक में स्टार्ट लेने के बाद एंड भी लेते हैं, कोई कोई वर्जन्स में। और इधर क्या है, धमद्र बुक में क्या लिए? स्टार्ट होने के बाद वो क्या लिए, उनका नेक्स्ट अपोजिट असेंबलर डायरेक्टिव स्टॉप लिया, बिकॉज जैसे स्टार्टिंग ब्रेसेस, ओपनिंग ब्रेसेस ऐसे रहते हैं ना, एवरी स्टार्ट ब्रेसेस शुड एंड विथ ए क्लोजिंग ब्रेसेस, so every start should have a end, that is nothing but a stop. So here what they have taken to begin the assembly program of the high level, ये कौन जनरेट करता है? इधर तक कंपाइलर करता है। कंपाइलर आपका सोर्स प्रोग्राम लिया, चलो सोचो कि आपका सोर्स प्रोग्राम कुछ कुछ 5 2 को कुछ कंप्यूट करके कुछ ऐसा प्रोग्राम किया, उसका ये सोर्स प्रोग्राम है। कंपाइलर इधर तक जनरेट करा, तो अब लेक्स क्या करता है? इसको लेक्स कैसे में कन्वर्ट करना, लेक्स इसको लेक्स का काम क्या है? इसको रिकॉग्नाइज करना है, ये क्या है बोलकर रिकॉग्नाइज करके वो डिवीजन कर लेता है। कैसे में? इंपरेटिव स्टेटमेंट है या डिक्लेरेटिव स्टेटमेंट है, ऐसे डिविजन्स कर लेता है, और जाके किसको देता है? क्योंकि फर्दर काम उसका नहीं है लेक्स का, फर्दर काम फिर जाके हेल्प लेता है उसमें सी कंपाइलर का। लेक्स डॉट वाई वाई डॉट सी है ना, ये इससे प्रोसेस कर लेता है, जो भी सी है उसको प्रोसेस कर लेता है, फिर जाके ऑब्जेक्ट फाइल बन जाता है। ऑब्जेक्ट फाइल फिर कैसे रन होता है? ./a.out, if you press enter button, it will generate the executable file. So in this way, Lex resembles only a lexical analysis. Phases of compilers are 6 phases. You should understand very clearly about a computer, a desktop, a PC, ये सभी compiler से होते हैं। Your mobile, everything is a compiler. Compiler means one thing you should understand, that it takes high level language, हाई लेवल को लो लेवल करता है, पर फिर लो लेवल करने के बाद हमको भी फिर हाई लेवल आना चाहिए, तो वो कैसे आता? वो एक्सिक्यूटेबल कोड बोलते हैं। ये आने के लिए सेट ऑफ अरेंजमेंट्स रहते हैं। कौन से अरेंजमेंट्स? असेंबलर्स रहते हैं उधर, असेंबलर होने के बाद मैक्रोस भी रहते हैं, क्योंकि फंक्शंस वो सब रहते हैं ना, मैक्रोस भी रहते हैं, असेंबलर्स, मैक्रोस, देन मैं मैक्रोस को छोड़ दूंगी, असेंबलर्स, लोडर्स, लिंकर्स। लिंकर्स तक ये काम करता है एवरी मशीन बोले तो कंप्यूटर ही। और उसमें एग्जाम्पल्स हम अंडरस्टैंड होने के लिए क्या करते हैं? टर्बो सी लेते हैं और हमारा ओन एग्जाम्पल डालते हैं, ओन प्रोग्राम करते हैं, ओन प्रोजेक्ट करते हैं। ये सब जावा, सी, लेक्स या ये सब क्या है? कंपाइलर्स हैं, और कोई भी प्रोजेक्ट्स कर सकते हैं उसमें। तो ये करने के लिए इंटरनली कैसा होता है? पहले हाई लेवल लैंग्वेज हमको मशीन को देते हैं, और मशीन क्या करता है, उसको लो लेवल करने के बाद फिर पास 1 पास 2 होता है, इंटरमीडिएट करता है। ये कौन करता है, असेंबलर करता है। असेंबलर का काम कहाँ तक है, ऑब्जेक्ट कोड। फिर ऑब्जेक्ट कोड जनरेट होने के बाद लिंक करना चाहिए, लिंक होने के बाद मेमोरी में लोड होना चाहिए, लिंक लोड इनटू मेमोरी, मेमोरी में लोड होने के बाद हमको वी कैन सी द आउटपुट। गेटिंग गणेश उनका।
जी आया है समझ में अब।
हाँ,
थोड़ा बहुत आया है, इतना
अच्छा
भी नहीं
अच्छा,
लेकिन आया है।
अच्छा अच्छा। ये देखो अभी नेक्स्ट स्टेटमेंट बोलेंगे आप, मैं इधर लिखूंगी, आप बोलो नेक्स्ट स्टेटमेंट। मूव एम, मूव एम, ये जो भी अब सी अभी ये क्या कर रहा है, स्कैन कर रहा, मूव एम को देख रहा, तो ये मूव एम कौन सा डिवीजन में आता, इंपेरेटिव स्टेटमेंट। और मूव एम का कोड क्या है, 5 है। मेन फंडा इज नथिंग बट ऑफ ए असेंबलर टू जनरेट द ऑब्जेक्ट कोड। ऑब्जेक्ट कोड डायरेक्टली जनरेट नहीं होता, उससे पहले क्या होता है, इंटरमीडिएट कोड, इंटरमीडिएट कोड विच इज नथिंग बट रिप्रेजेंटेटिव कोड। फिर इसको भी फिर बहुत रिफाइनिंग करता है, जैसे अभी मैंने वेरिएंट 1 वेरिएंट 2 दिखाया, बहुत रिफाइनिंग करने के बाद पास टू लेता है। पास टू क्या करता है, बहुत ही रिफाइनिंग करके ऑब्जेक्ट कोड देता है। वो एक लास्ट एग्जांपल दिखाई थी ना इधर, दिस वन, ऐसा रहता है आपका ऑब्जेक्ट कोड। लोकेशन काउंटर भी दिखाता है, ये रहता है। ये हम सॉल्व करेंगे बोल रही मैं, लेकिन कोई भी सुन रहा ही नहीं क्लास। ये फिलहाल ले लो, ये लैब प्रोग्राम, फिर लैब प्रोग्राम भी हो जाएगा, फिर वन डिजाइन पास भी हो जाएगा, और इससे आपको भी अच्छा लगेगा, सबको अंडरस्टैंड भी हो जाएगा। ये ले लो जो मैं दिखा रही हूँ, इसको प्रोसेस करो इंटरमीडिएट कोड में। दिस इटसेल्फ इज पास 1। पास 1 में क्या है, जितना काम हो सकता है स्कैन वो कर लेता है। पास 2 में क्या होता है, जो पास 1 नहीं किया वो काम पास 2 कर लेगा। ओके, और वो चुनेगा सिर्फ कोड ही, सब कोड हो गया क्या नहीं, सब कोड ऑब्जेक्ट कोड बन रहे कि नहीं, सिर्फ वो चुनेगा पास टू कोड ही। वो पास टू सिर्फ कोड चुनेगा, ये इंपेरेटिव आईएस ये सब छोड़ेगा। पास टू सिर्फ इधर 1 लेगा, 4 लेगा, और ये फर्स्ट लाइन में 1 लेकर 200 लेगा। 200 भी ये नहीं लेगा, क्योंकि बोले तो उसको पता है 200 लोकेशंस में शुरू हुआ बोलकर, फिर वो भी छोड़ेगा। मीन्स इधर ऑप्टिमम स्टैंडर्डाइज लेता, क्या जरूरत है उतना ही लेगा, क्योंकि पास 1 पूरा काम कर लिया, पास 2 क्या जरूरत है कोड जनरेट करने के लिए, ऑब्जेक्ट कोड जनरेट कर उतना ही लेगा। मीन्स रूटीन पे जो काम रूटीन पे बन रहा है उतना ही कन्वर्ट करके मिनिमाइज करके वो पास 2 लेगा। अभी ये बोलो मूव एम क्या हो रहा है इधर, क्या अटेंडेंस ले लो, आप लिखेंगे ना नेक्स्ट कोड इधर क्या आता, आप बोलिए मुझे। AX BX, AREG मीन्स A रजिस्टर, BREG मीन्स 2। ओके, इधर AX रजिस्टर्स का कोड मैं नहीं दिखाई, बुक में भी नहीं दिया, शायद 8086 बुक में दिया होगा AX BX रजिस्टर्स, नहीं तो कहीं इंडेक्स पे देता है, कहीं बिब्लियोग्राफी में भी देता है कभी कभी। सो यू शुड सी देयर, और एल्स यू कैन गो विद द बुक ऑफ the 8086 textbook, any textbook, wherever you go you will be finding the categories of registers code. Okay Pranesh, A को 1 रहेगा, B को 2 रहेगा, C को 3, D को 4 रहेगा। तो इधर B है तो कोड क्या आएगा 2, कोड क्या आएगा 2। तो फिर से इधर लिटरल है 5, ये कौन से कैटेगरी में जाएगा, ये ऐसा मीन्स पास 1 क्या है, अरे ये 5 क्या है, 5 लिटरल है, तो लिटरल टेबल में जाएगा। तो इसको सिंबलाइज करता है इधर, क्या बोलकर सिंबलाइज करता है, I have seen something like equal 5 with single quote. So it will identify it as the, it will identify it as the what, the literal, as पहले लिटरल है कोई है तो उसके टेबल में, तो ये सेकंड हो जाएगा, अगर कोई भी नहीं है पहले बोल तो ये 1 हो जाएगा। तो इधर कौन कौन सा आएगा, ये सेकंड टाइम जा रहा लिटरल टेबल में, तो ये L, 02, इसका इंडेक्स वैल्यू क्या होगा सेकंड आदमी है ये, पहले आदमी कौन था, इक्वल टू 2, पहले सेकंड आदमी कौन है, इक्वल टू 5। सो जैसे ये ऐसे नोटेशंस है, ये लिटरल्स बोलते हैं। ये लिटरल्स कैसे बन रहे हैं, वो जो भी सोर्स कोड है उसके हिसाब से ये बना है, सोर्स कोड्स के हिसाब से। ओके, हम इधर एग्जाम्पल ले रहे, और इधर क्या हो रहा है, एल टी ओ आर जी। एल टी ओ आर जी जैसे ही एनकाउंटर होता है, एल टी ओ आर जी क्या करता है, दो काम करता है। दो काम बोले तो इसको कैटेगराइज करता है डीएल पे। वाई डीएल, डिक्लेरेटिव स्टेटमेंट। और एल टी ओ आर जी का कोड क्या है, 05 है। एल टी ओ आर जी का कोड क्या है, 005, सॉरी 02 है क्या, 05 है। एल टी ओ आर जी इज 05, LTORG is 05 because I have shown in variant example also. See what is the LTORG code here, 05. See here, LTORG is a declarative statement and it is advanced declarative statement and its code is 05. Once LTORG is encountered, a pool table begins internally. क्या होता है, a pool table begins. Let me take attendance now. Pranesh, Pranesh.
नहीं मैडम, ये मैं कैसे बता सकता हूँ, मुझे क्या अधिकार है, आप वर्ग प्रतिनिधि से पूछ लीजिए।
हाँ
आप वर्ग प्रतिनिधि से पूछ लीजिए इसके बारे में, मैं नहीं बता सकता।
बोले तो,
क्लास रिप्रेजेंटेटिव।
oh. They are not responding only, no Pranish. Okay, let it be whoever is the student. But anyhow, I have last 15 minutes. Again, I will be having the means, ma'am, only 15 minutes they will be telling. Okay, I'll take attendance. Are you seeing this? Continue the example. Okay. Next add है, देखो solve कर लो। add को क्या कोड मिलता है, add add 4 लिया है। मैं पिछली एग्जाम्पल में एक दिखाई ना, सब सब कितना दिए लिया था, वेरिएंट एग्जाम्पल में, इधर है देखो, सब लिया था 02, सब लिया था क्या 02, तो ऐड कितना हो गया 101, तो ऐड कितना हो गया इधर, उसका कोड, ऐड का कोड क्या है, ये इंस्ट्रक्शन का आई मीन ऐड इज ए इंपरेटिव स्टेटमेंट एंड इट्स कोड इज 01। ओके, गिव मी अटेंडेंस 1 2
Present.
2
Present, ma'am.
3 4
Present, ma'am.
5
Present, ma'am. 4.
6
Present, ma'am.
7
Present.
8
Present.
9
Present, ma'am.
10
Present, ma'am.
11
Present, ma'am.
12
Present, ma'am.
13
Present, ma'am.
14
Present, ma'am.
15
Present, ma'am.
16 17
Present, ma'am.
17 18
Present, ma'am.
19 20, please hurry up na,
Present. Present, ma'am.
21
Present.
22. Keep your mute na when the next number is going to be answered. Only you people do with my class. I have seen Shekdar ma'ams, everybody, you people are very attentive. I don't know why for me, my class. Okay, let it be. 23
Present, ma'am.
24
Present.
25
Present,
26
ma'am. Present, ma'am.
27 28
Present, ma'am.
29
Yes, ma'am.
30. Those who have I have taken the attendance, you just you can unmute. 27, sorry, 28, 29,
Yes, ma'am.
30, 31,
Yes, ma'am.
32, 33,
Yes, ma'am.
Present, ma'am.
34,
Present, ma'am.
35, 36,
Present, ma'am.
37, huh,
Present, ma'am.
38,
Present, ma'am.
39,
Present, ma'am.
40,
Present, ma'am.
41,
Present,
42,
ma'am.
43,
Present, ma'am.
44, 45,
Present, ma'am.
43
46.
present, ma'am.
Okay, okay. 46, 47,
Present, ma'am.
48, 49, 50,
Present, ma'am.
51,
Present, ma'am.
52, 53, 54,
Present.
55, 56,
Present.
57,
56 present.
57, 50,
Present.
huh,
Present.
okay, 58,
Present, ma'am.
59,
Present.
60, 61,
Present, ma'am.
62,
Present,
63,
ma'am. Present,
64,
ma'am.
65,
Present.
66, 67,
64 present, ma'am.
Present.
huh,
66 present.
67,
Present.
68,
Present.
69,
Present.
70.
Present. 64 present, ma'am.
Okay, okay. I have
59
marks.
present, ma'am.
Today totally 9 students are absent.
Hello, ma'am.
27,
Can you
30.
repeat?
Yeah, I am repeating. 27, 30, 35, 46, 48, 51, 53,
51
50.
present, ma'am.
51 present.
51.
Okay, okay.
Ma'am, roll number
50,
35 is present due to mic problem. She is
hmm,
unable to mark attendance. Roll number
53,
35, ma'am.
53, and 56, sorry, 55,
55 present, ma'am.
and 70 is absent. Sorry, 70
Ma'am,
is
66
also
55
present.
present.
ओके ओके, पर इधर तो 61 थे, सभी लोग प्रेजेंट ही हैं। ठीक है।
Hello, ma'am.
यस,
46. She was attending Rubicon session, ma'am.
रूबिकॉन, वी शुड गिव अटेंडेंस।
Yes. Yes, she wrote in chat box.
ओके, 27, 30, 48, 53 आर एब्सेंट।
48 is present.
Ma'am, 43 is present.
आई डिडंट टोल्ड 43, ओके, आई टोल्ड 48।
48 present, ma'am.
हाँ,
Okay, ma'am.
there is no rule only in attendance, all are telling present। Okay, next class will be on macros, and before that I'll be talking on the forward reference in the next class. Till then, solve that example what I have given, and most of you have not forwarded me the quiz because I'm not getting time here to be solved because I'm lagging the class. That's what I have not taken the quiz in the class time. So you please forward your answers in the link to the link so that I will get the answers, and later after getting all the answers I'll release the answers of that so you can clarify it. First let me know how many of you have done the answers. So before that, take this assignment and rest remaining generate the intermediate code. Are you taking? I'll just put that into the screenshot. Next remaining generate the I'll just take half only. For the next class, tell me it's
Hello, ma'am.
yes, tell.
Ma'am, my roll number is 64. Due to network problem, I am not able to give the attendance.
रोल नंबर 64. हाँ, ठीक है.
Yes, ma'am.
ओके.